Welcome back everyone and good evening to all. So welcome to this interactive session series for the course on Introduction to Multimodal Urban Transportation Systems. So this is week number 10. So let's start the session today. So as you would have already known that generally we discuss some important questions, some are theoretical and some are numerical in nature, right? So the session will start from the theoretical questions and then we will come to the numerical ones, right? So let's start then. So first I would like all of you to participate or try attempting these questions or trying guessing the correct answers before I tell you what is the correct answer, and then I will discuss, right? So you may comment on the chat box, right? So the first question is, which of the following is not an ITS based data collection technique? So which of the following is not an ITS based data collection technique? So as you have already go through the course material and also would have already seen the videos like the course lectures. So this particular 10th week course material is almost entirely based on the intelligent transport system and its component, its architecture and so on, right? So before we say that what is an ITS based data collection technique, so we should know what is an ITS. It is full form is intelligent transportation systems. So maybe you can imagine it's an intelligent transportation systems. So but it is not entirely true. It may be applicable to the transportation systems, but you need to make the transportation system intelligent, you need other engineering components also, right? It's not only the work of the transportation people to make it intelligent, because you need some other kinds of aspects also, right? So basically if we see the definition of the ITS, so it is the application of electronics, communications, the information processing technology that is used either in an isolated manner or in a combination, right, to improve the efficiency or safety of a surface transportation system. So what is the surface transportation system? The surface transportation systems are these transportation systems which are plying on roads, right? So also it may be applicable to other kinds of transportation systems also sometimes, but generally it is broadly applicable to the surface transportation systems, right? So you would have already see that in India also we are building new expressways, right? Urban expressways, like Mumbai, Pune expressways and all. So basically they are also our honorable ministers. They are actually also trying to developing the ITS facility along this expressways, right? So basically final aim is to make your transportation system intelligent and so that its efficiency and safety could be enhanced, right? So system efficiency means you would have less travel time, there would be faster movement of vehicles, right? Those kinds of things. It will be reliable also, right? Then the less accident prone, like safety should be enhanced also, right? So this is called an ITS. This is the main function of ITS. So now as we already know that ITS architecture has main four components. First is the enterprise needs. So you need to identify who are the stakeholders and what are their needs, and then comes to the functional part of this ITS. So functional part means how your data should flow, right? So that direction has to be like, that is called the functional thing. And the physical is what are the basically equipments and other things that will be needed. And finally the communication using 3G, 4G, 5G, right? You need to communicate. So if I give you an example of how we collect the GPS based data collections by deploying GPS devices on bus or car or other vehicles, right? So suppose your enterprise is either your uh, transportation uh, researchers and means transportation department maybe, or maybe it can be your traffic engineers, right? So now your enterprise needs are those stakeholders, they are needing that system, they want that data to analyze something, like to come up with something. So now you see your functional thing is what? Functional thing is that you have suppose a GPS system and you have a database placed in your suppose in a traffic management center. So now your data has to flow from bus to database, right? It's not the other way around. Maybe for some other kinds of system it may be bi-directional, but here your data is there, it needs to be translated or needs to be transferred to your main database where traffic management center is located, so that they can analyze the data, right? So then your physical part is how many devices are needed, do we need separate GPS for separate buses, or what is the thing? So those are called the informations, right? And then finally the communication. So how your communications from the GPS server to the from the GPS receiver to the final destination will happen. Is it the GPS service or something else? So this is broadly ITS, what it means, right? So now then triangulation, trilateration is site-based data collection. Site-based data collection means it may be consist of videographic survey or maybe some kind of other kind of survey, right? Then the perception survey. So which of the following is not an ITS? So triangulation actually it's a surveying technique, whereas trilateration uh, is the distance technique that is used for locating the position of a vehicle at a particular time, right? That is called trilateration, and direct example is the GPS server. So like if you have mobile phone, so there is a GPS receiver. So now if your GPS signal is on, then actually your location information can be stored, right? So that is called the trilateration technique, using trilateration technique. So then it's an ITS based data collection. And then finally is the perception survey. So perception survey means you have developed a questionnaire. Now you will go to your particular site. Suppose you want to improve the water transport service. So you want to go to the where the water service already existing, right? Like different ghats, you can go and you can ask people questions regarding what is the importance or what are the attributes which are important. So this is not an ITS based data collection technique at all, right? So it is a manual based. So the correct answer would be here D. So let me highlight them. So the correct answer would be perception service. Right? So this is next one is blind spot monitoring is an example of which type of vehicular communication. So nowadays, as our ITS system is growing, so we have what? We have vehicle to vehicle connection. So already you would have already known the automated vehicles concept, which is running, like automated and connected vehicles, like connected and automated vehicles, CAVs, right? Or automated vehicles, AVs. So basically your vehicle can talk to the other vehicle, right? In terms of many aspects, in terms of speed, in terms of distance, what is the space between two vehicles and all. So then the vehicle to infrastructure is, suppose you have a signal that is placed, you have a smart signal that is placed at an intersection. Now you have a vehicle, right? Your vehicle and infrastructure are talking, like what are the green time that is needed, for a particular vehicle to pass, or what is the time that the vehicle will come close to the intersection. Those kinds of communication is the vehicle to infrastructure. And vehicle to everything means vehicle can talk to everything. This is an like ultra level, or you can say this is an highest level of vehicular communications. So I would like the participant to answer in the chat box, so that then I will discuss. So what is blind spot monitoring, and like like is it vehicle to vehicle communication is happening through blind spot monitoring, or vehicle to infrastructure, or vehicle to everything. So the idea is, since this is an interactive session, I do not want to directly say, tell you the answer. Rather, I would wait for you to respond. At least you try. Then maybe I will discuss. Or if you have any queries, you can also ask. Right. So I can directly say, but I will wait for a few seconds before I will say you what is the blind spot monitoring and what kind of communication is falling under this blind spot monitoring, right? So I will wait for few seconds. So basically, what is a blind spot? I am giving you the clue. Blind spot, if you have a vehicle, so if you want to see the rear end of the vehicle, generally we see the error drivers in a vehicle, in a car, see the basically the mirror and try to see if something is there in the rear side, right, or the back side. So but what happens, just immediately behind the vehicle, it is not possible for you to see, right, while you are driving. So that is called a blind spot, and for that sometimes accident are happening, and this is an like people have seen that evidence is there that because of this blind spot, actually many times actually accidents occurred in the past and also currently. So then, how do you monitor that blind spot so that it should be enhanced, right? So let me tell you the answer. It will be vehicle to vehicle. So suppose you have a vehicle here, and your vehicle is saying that you have a vehicle maybe 50 meters away behind you, and maybe the angle and other information and the speeds. Then you are actually, you know that there is a vehicle, so whatever you will do accordingly to avoid the accidents, right? So it will give you a kind of uh, warning, right? So it is then vehicle to vehicle interaction system. So third one is, which of the following data is collected to estimate the public bicycle sharing system, which is called PBS, that demand according to the document, Indian document, 2016 version, right? So for estimating the public bicycle sharing demand, so suppose you do not have any bicycle sharing system in your city, so you want to develop a public bicycle sharing system in your city, right? So what are the data that you need? So what is your final goal? So final goal is to estimate the demand. So what is the demand, which time the demand is arising. Based on that, you will say that these are the places and these are the vehicles that I need to deploy so that people will use it, right? And maybe these are the lanes that we need to build for bicycles. So which of the data has to be collected, right? Is it user perception survey? So what is a user perception survey? So you go within questionnaire and then you ask what is your gender, would you like to use public bicycle sharing if I give you this, or what are the trips. Maybe you can use your bicycle for some leisure trip, but you may not be willing to use it for work trip purpose. Maybe your work is your work trip maybe is a long trip, right? Is a maybe 10 to 12 kilometer or something, so you do not want to use it. So based on that, you want to do a public user perception survey. Then second one is a household travel survey. So you can go house to house and you can ask that generally like how many times you are traveling, which mode you are using, then what is the trip purpose every time, and then weekend at what time you are actually leaving from your house. Those are falling under household survey, right? So then your secondary data. So data which is already available in the website, maybe municipal website or something, that is called the secondary data. And then the final is all of the above. So which of the following data is collected to estimate the previous demand? So actually if our main intention is to estimate the demand, then I need all the data, because I need all the information, so that now I know which route to prioritize, and which time period to prioritize, and also how many bicycle I need to deploy, or that also comes under the what is the investment that has been needed, right? So it will be, the answer will be all of the above. So then the fourth one is, what is the mathematical study of delays in waiting in line? So suppose you went in a market, right, or in a mall. Then after buying your item, you want to now bill, you want to process your bill. So you are waiting at the counter, right, billing counters. So that is a queue. Similarly, vehicles also queued, at which time, maybe at the toll booth, right, or maybe in a jam also they can queue near by a signalized intersection or something. So then what is the study that is concerned with this delay of waiting in line, what is this called? Is it called the queuing theory in mathematics, or is it called the arrival process, or is it called the service process, right? So I think it is very straightforward. So should I expect that you will be giving an answer in the chat box by writing A, B, C or D, whatever you feel? So it's not a problem if it is correct or wrong, it is just a participation that is appreciable. So since it's a study of delay in waiting time, so actually this theory, actually in mathematics it is called the queuing theory, right? So what is the arrival process? Arrival process is your arrival, or the vehicle is arriving at the counter, or here the toll booth, right? So if this is a toll booth, vehicle is arriving. So that process may be random, maybe something else, right? Maybe deterministic. So that's called a arrival process. And what is the service process? So how actually you are serving those vehicles. So if you have a toll booth, now suppose you are these vehicles are you are serving, and this is you served. So that's called a service process. And what is your queuing theory? Queuing theory deals with all those elements, not only arrival but also the service, and then also the departure process. Let me go to the next question. So now the question is, calculate the queuing delay time in a manual toll plaza if there are total 5 toll booths and your only single lane is available at that highway, right? Although generally we have more than single lane, but for the sake of example, it is a single lane highway, right? So then that total traffic flow is given as 1200 vehicles per hour, right? And the service rate is given. Service rate means at the rate, at this rate actually the toll booth is serving the vehicles, right? So that is called 10 vehicles per minute. So per minute 10 vehicles are served in a particular counter, right? And you have total 5 toll booths. So then second one is, you calculate again the queuing delay time of a similar toll plaza or the same toll plaza. Now you upgrade it with the electronic toll collection system. So automatically it will detect your number plate and then send you the challan, or send you the maybe receipt, right? Or maybe automatically withdraw the money if it is connected to some kind of smart card or something, right? Or maybe directly in your from your bank account. And then your service rate is 20 vehicle per minute. So your service rate increases because it's an automatic one. So now you need to calculate what is the queuing delay time, right? So the formula is, to calculate your queuing delay time is this, 1 by, this is mu minus lambda by what? Lambda by, maybe you can call it a t. So mu is your service rate, lambda is your what? Arrival rate. and T is the number of toll booths minus 1, because if you have 5 toll booths, then you would have 4 merging lanes, right, at the departure side of that. So that's why you can consider it's a 4, because here it is a 5. So it is very straightforward. If I calculate it for the first case, so mu is what? Mu is 10 vehicle per meter, that is the mu. So now if I convert it to the vehicle per hour, then it would be per minute into 60, then 600, right? Then your lambda is what? 1200 vehicles per hour. This is the total traffic that is coming, that is the arrival rate, right? And your T is 4. So now if I calculate, what would be the value? 400, 4 into 300, then 1 by 300 would be the value, right, in hour. And then for minute 60, and for again seconds, so 12 seconds. So your answer would be 12 seconds for this will be your queuing delay, right, per hour queuing delay. So now if you upgrade it to ETC, what would be the value? So everything will remain same, just your 20 will be 20 into 60, because per hour it is per minute it is given. So per hour means into 60. So then it will be 1200, and rest of the everything will be same, right? So this value will be replaced by 1200. So then your 1200 minus 300, it is a 900. 1 by 900 is some value, and then seconds is 4. So it will be 12 seconds and 4 seconds, right, per vehicle obviously. So 12 and 4, the rest of the values are not matching, so A would be the correct answer. So do you have any difficulty in calculating or understanding this problem, or shall I wait so that you can also calculate and try to see if your value is also matching with my value? Shall I wait or shall I continue? If you can write it in the chat box, or maybe unmute yourself and say something. Although it is very straightforward, only a matter of unit change per meter per minute to hour. Tell me. Okay, you got it. So then the next question is, what principle determines the exact location of an object using GPS receiver? Is it triangulation or is it trilateration? What do you think? What principle has been used to find the exact location of an object using GPS receivers? Your mobile phone is also a GPS receiver, right? If you switch on your Wi-Fi, then it is also a GPS receiver. So what is the principle behind locating the location of an object? Is it triangulation? Is it trilateration? What do you think? These are not exactly same procedures. Do you want to answer? If you trilateration, so why not triangulation, and like how it is different from triangulation? Tell me that what is triangulation? So generally this is used in survey. If you know how the survey has been done, so suppose you have a river here, so you have a chainage here AP, you know the distance is something, and now you know that from here you are using an instrument, theodolite or something. Now you know that here you have some point C, which is the point of interest. Now you know the angle of this and angle of this, right? So now if you know the angle, then you know the AC distance also, you know BC distance, you know this angle, so everything is known. Although you have river, just from point A, you know by using kind of theodolite survey, you know the angles, maybe vertical, maybe horizontal, whatever it is, then you know the angle. If you know the angle, if you know this angle, then you know this angle, also you know the each and every value, so what is the distance, right? So this is actually called triangulation in survey. And what is trilateration? Trilateration is, suppose at your current place, right? Suppose there are two satellite which are giving you signals. So there are many satellites which are actually revolving around the earth, right? So maybe at a particular time there are two satellites and your mobile's GPS Wi-Fi is on, right? So now based on these two signals, you can know that either you are in this location or in this location, because this is the intersection of two locations. Suppose you are having only one GPS, what I say, one satellite which is sending you the signal at a particular location. So then we know that you are in this bound, but we don't know the exact point. So now if you have two, then we know that either you are here or you are here. So now if we have three, so we know that your location is this, not this. This is not your location, this is your location. So this is fundamentally called the trilateration, right? So now that is why it is important that if you want to know the exact and precise location for a particular object or for yourself, wherever you are standing or sitting or whatever, so you need minimum 3 satellites for your location information and 1 satellite for your time, because time is also they are using atomic clock, right? Because whenever GPS is sending a signal to you and then receiving a signal, so it will elapse some time, right? Some time will be lost. So you need another satellite for time. Right? So for precious location and time, you need minimum 4 satellites, but for only location, you need only 3 satellites, right? So this is called trilateration survey, right? So now let me go to this numerical. So which is saying that determine the position of a car which is 22, 54 and 62 kilometers from the cell phone towers S1, S2 and S3. So this is S1, this is S2 and this is S3 and this is S2, right? So S1 is 22, so this distance is 22, S2 is 54, so this distance is 54 and this is 62, right? So the distance between tower S2 and S3, so this distance, it is given as 60, right? So now assume the driver is carrying a cell phone which could be used for trilateration. Yes, driver should have a cell phone or something GPS receiver, otherwise we cannot locate him, right? That signal has to be there, otherwise how GPS will connect to you, right? So then it is in XY plane also, it is not on any other plane, right? So then what is the location of the car? Suppose considering ki suppose this is your y, positive y, and this is your positive x. Suppose this is also given. So now how do you calculate that from x what is the distance, right? How to calculate this? This is given 22, this is given as 62 and this is given as 54. So suppose this is your location. So now we know that this is a 90 degree, right? This is a 90 degree. So this is D3. So now you know that D3 square is equal to D3 square is equal to perpendicular, this is 1, if this is y, so this is y square, and if I say that this is y and this is x, just this value is x, right? Only up to this, and total value is 60. Right? So then base plus perpendicular square is equal to d3 square. This is equation 1. And from this triangle, you know this is 54. So this is d2. d2 square is equal to, now this distance is what? If this is x, then it is 60 kilometer minus x, considering x is in kilometer. This square plus your perpendicular is y, right? So now can you calculate with these two equations and tell me what could be the correct answer? I will wait for your calculation. And if you have a problem or difficulty in understanding the equations, you can also tell me. I will try to repeat and try to clarify it. Right? I do not want to do this calculation. I want you to do it first, so that you can solve it easily. Because later on there will be examinations in NPTEL, right? And also you need to solve your assignments. So it's better, it's a kind of practice thing, right? So can you do it? You already know that d3 value is how much? It's 62 and d2 is 54. Those two are known. And your y is same, y is there in the two equations. So now if you have two equations and if you have two unknowns x and y, so you can easily solve it. That we already know from our mathematical concepts, right? So it's a determinate thing to solve. So shall I do it or shall you do it? Or you are already doing? I think you are calculating, so I am waiting, so that you will come up with some answer and then I will recheck. X is 37.5. Can you calculate once again? I don't think you are right. Okay, you calculate, I will also calculate along with you, right? So that we can come with the same answer. So now what is my d3? d3 is 60 kilometers square equal to x square plus y square, and here 54 square is equal to 60 minus x square plus y square. So then your y square is 62 square minus x square is equal to your 54 square minus 60 minus x square, right? So then your 62 square minus 52 square is equal to x square minus 60 minus x square. So x square minus 3600 minus 120x plus x square plus 120x minus x square. So then 120x is equal to 120x is equal to 60 PQ square minus 54 square. Okay. 28 plus 3600 by 1. So what is your y? 37.73 I am getting. You are getting 37.5. Am I correct? Although these are values are close, but I think you should have also get the same thing. I think if you recalculate, I think you will also get the same answer. Right, so this is x and y value. So now if we have any other questions, okay. So this is from my side for today. Now if you have any difficulty for any assignments or uh, any of these course material, so then you can ask. Then after that we will end the session. I think this week's materials is not troublesome or not too difficult to understand. Things are actually interesting and also at the same time very straightforward. Most of the problems. This is what I feel. So now tell me if you have any doubts. Then you can ask. You can clarify. Right, this also you can recalculate. I think you will also get 37.73. If you have done it correctly, then I think you will get. So if you missed, did you missed anything? So this is the first one. If you have missed, so it is the which of the following is not an ITS based data collection technique. So perception surveys are usually questionnaire surveys, right? So there is no ITS involved. It is a manual thing because it's a perception survey. So you want to go to them, to the people, and based on their perception they will answer. So there is okay. So suppose right now I want to know that what is the why your suppose you are using bus transportation systems, right? Suppose you daily for work trip you are using bus. Now you are complaining that no, bus is not good due to these are the reasons, right? So then I need your perception to improve the service. So if you are saying that your service is not comfortable, so those questions I will make. There's these comfort for comfort one questions for this and for that, or maybe you are saying something and I am also a commuter. I am saying that it is not reliable, and you are saying it is not safe. So those are different things. So based on socio demographics like age, income, gender and other things, I will design a questionnaire by saying that which of the following things that you are not satisfied. So suppose you are saying that for safety I am not satisfied, for comfort I am not satisfied. Now how much you are not satisfied? You are saying that on a scale of 1 to 7 I am not at all satisfied, so that is 1, that is a poor rating. So like that I will develop a questionnaire survey. I will go to a bus or near the bus stands, and so that I want to know that for that particular bus service what is the problems that commuter are facing, like what is your perception about the service. So these are called perception surveys, usually in the questionnaire form we are doing, right? Questionnaire form, maybe sometimes we develop questionnaire, then we share with in the form of Google form, or directly we can mail them the Google form, right? So this is called a perception surveys. Is it clear? Okay. Tell me if you have any more doubts or clarifications that you want to. Okay. Then we will meet again at the same time, at the same day next week, Friday, for your week 11. And some questions I will develop and I will come up with the solutions, right? The same way that we have discussed for today. So thank you for joining and listening to me. So now I am closing the session for everyone, right? So thank you.